Hi, China. I see we have Carissa, China, Prince, and Tyler.
Hello.
Can you guys hear me?
Yes.
Yes.
Can you all hear me?
Yes.
Can you hear us?
Yeah, I can hear you.
Sorry. Okay, my volume was low. All right, so I'll go ahead and begin. And I just quickly wanted to, before I go into chapter 9, to quickly walk you through what's going to be on that final test that you're going to have this week. And before I begin, did you guys have any questions specifically that you want me to address? Okay. I'll assume silence means no questions. All right. So
can you hear me by the way?
Yes, I can. Is that Prince?
Okay. Yeah, this is Prince. My headphone was acting up, but I think I got it going now. Thanks.
Okay. Okay. All right. So for the final exam, you're going to have again, it's going to be theory based, basically testing the theory behind every chapter covered in the 4 different modules we covered for management science. And I listed a couple of things that I wanted you to take note of as you go through the test. A couple of things that I would like you to take from the course is from the first chapter, what is break-even analysis, and what are the different things that what's the theory behind break-even, and then moving on to linear programming. You should at this moment be able to distinguish between what a variable is and a constraint. You should be able to determine what's a decision variable, what's an objective function. Those are things which at this stage you've had to write down a couple of times, and so they should be easy to bring back to memory. I also would like you to know the theory behind why we do sensitivity analysis. What's a sensitivity analysis, and what's the objective of actually running a sensitivity analysis? For our last module last week, when we talked about binary integer programming, go through a discussion of and try and revise what is binary integer programming, and what differentiates it from the other types of linear programming that we've done in the past. Okay, what's that word binary? What does it stand for? And how does that then make it slightly different from what we've done in the past? Okay, for this week's content, as we look at decision analysis, try and understand what are the different approaches to decision analysis. If you talk of a mini-max or a mini-min approach to decision analysis, what are those? And hopefully today's Zoom session should enable you to get a better understanding of that. Okay, so again, you'd have a series of 20 questions, a mixture of true, false, multiple choice, and fill in the gap type of questions. So that should be, if you got to understand the contents of the different chapters, it should be a walk through the park for you. Okay. Any questions on that last component?
Will the time limit be an hour and a half again?
Yeah, it'll be an hour and a half. So it should be sufficient time to get through the exam. It'll actually be 100 minutes, so an hour, 40 minutes.
The reason I'm asking this is on the last one I ran out of time, and there was like 4 questions I didn't have time to answer.
Oh, okay.
But since I'll be more like prepared this time, so I think it'll be fine.
Did you exceedingly run out of time, or was it just a couple of questions?
I had like 4 questions left and run out of time.
Okay. So usually when I set up the time limits, I I actually go through the exam and see how long would it take me to get through it, and then I multiply that by 2. I'll review again to see whether 100 minutes should be enough. I think I would have thought it would be enough, but I'll check quickly and just make sure that 100 minutes should be enough.
And I think I wasn't, I don't know. I think I'll do better on this one with the timing. I'm not I take forever on tests in general. So since I know what to, the time limit and stuff now, I'll kind of prepare for that a little bit more. I just wanted to see what the time limit would be, so I knew.
Okay.
Thank you.
All right, thanks. All right. Any more questions before I jump into discussion of chapter 9?
I had one question for the last test that we took, just because I don't want you to run out of time.
Okay.
When are you? I was looking for the grade for it, but I don't.
You should have your grade for that.
I didn't see, because I thought you were the syllabus said that you would modify the grade and then put the real points in there, because I just got what the system graded.
Okay, let me check on that, because I actually went and I adjusted a number of grades. I thought I'd done it for all of, but let me check and see.
Okay.
Yeah, Professor Achia, you said that the test needed hand grading, and you would.
Yes, it did need hand grading. So if you find that yours isn't hand graded, where you'd see like a 0.5 or something like that, then I'll review all that right after this.
Okay, I appreciate it. Thank you.
Yeah. All right. Let me quickly go over chapter 9. And if you'd notice, for chapter 9, it asks quite a bit that you use RSPE, which I don't want you to use because it's an extra software which is, as a business student, I don't really require you to use it, because once you get out of Gardner Web, you're never going to see it again. So I find it redundant in that regard. So as we go over chapter 9, just know that whenever you see RSPE, I don't require you to do that portion of the chapter. Okay, so chapter 9 talks about decision analysis. And for this specific section, what I'm interested in is the very first portion of chapter 9. So I don't require you to, it'd be nice for you to browse through the whole chapter. But what we're interested in for the purposes of this course is actually the first 4 or 5 topics. Okay. And I like how it goes through the topic in that it provides us with examples with step-by-step instructions on how to go about making a decision in situations of uncertainty. And so I'd like to walk through a bunch of these. And as we go along, if you have a question, just let me know. We'll stop, answer your question, and then move along. Okay. So decision analysis is used in situations where you have you're faced with multiple decisions, not just at one level. Usually, almost all questions that involve decision analysis require you to have a multi-stage decision-making process that you at each stage you have multiple options available to you that you need to try and figure out what's the best possible option that will result in the best possible outcome. Okay, so the book gives an example of, say, a manufacturer introducing a new product, and the couple of questions that he might ask himself is, what would be the reaction of potential customers? And you notice that the answers to every question here will usually be, there'll be 2 or 3 or 4 different or potential outcomes or options available to whoever's making the decision. Okay, so what would be the reaction of potential customers? That could be positive or negative. Okay, how much should be produced? A little, a lot. There could be different ways to answer that. Should the product be marketed? Yes, no. So you'll see here that the decisions at every step, and usually one decision precedes another decision, and so you end up having a whole bunch of different outcomes. And so the overall objective here is for us to determine what's the best possible outcome given the information we know today, and that'll enable us to determine what outcome should we pursue given the information that we have. Okay, so I'll walk us through 1 or 2 problems, and that'll give you a better idea of what decision analysis is all about. Okay, so the textbooks talks about the go for broke company, and this is a company that drills for oil. And we're told that a geologist has reported that there's a 1 in 4 chance or 25% chance of finding oil in a particular piece of land. Okay, if they were to drill for that oil, it'll cost them about $100,000. If the tract contains oils, then they expect to generate $800,000 worth of revenue. At the same time, a second option available to them is that there's a company that's willing to purchase that tract of land for $90,000. Okay, so this is a very basic but typical type of decision analysis problem that you might have. Okay, you have competing options available to you, and you want to try and make the best possible choice given those options. Okay, so let me move on. Let me move to Excel, just because I find thinking Excel much easier. Okay, so if we look at the information that we have here, it can be broken down to a couple of things. One is something which we call the prior probability. Okay, so going into this whole analysis process, the geologist comes up with a subjective value that he believes is a probability associated with either getting or not getting oil out of that tract of land. Okay, so this is subjective, and that has issues, but for the purposes of making a decision, you have to start somewhere. Okay, so in this case, we're told that the geologist believes that there's a 25% probability that they can find oil, and that alternatively means that there's a 75% probability that there'll be no oil. Okay, we're told that there'll be an initial investment of $100,000 if they decide to drill, and there'll be no investment if they decide to sell the tract of land. Okay. And the final thing that we're told is that if they decide to, let me go back to this. Oh, that's 800,000, not 8,000. If they decide to pursue the drilling option, then they end up generating revenues of 800,000. Okay, as opposed to selling, where if they sell, the revenues generated actually is just the cost of the sale price of the tract of land, which we're given as 90,000. Okay. So with this information in mind, the question that we have to answer is, should we or should we not sell the tract? Okay. So decision analysis has a couple of approaches to this, from the very basic to approaches which are way more complex. So let's start with the basic approaches and look at these here and minimize my screen. So we have what's called the Maximin Criterion that can be used to quickly find out a solution to this issue. Okay, and the Maximin Criterion basically says that look at amongst your different alternatives, look at the one that gives you the maximum returns, and use that as your criteria. Okay, so in the information that we're given here, okay, we're looking at what's the alternative that will result in the maximum amount of profit or revenue for this company. Okay, so we are told, let me go back to our data here, that the company would invest $100,000 to drill, and if that's the case, then the net revenues here would be the difference between the revenues generated and that investment of 100,000. Okay, so with the Maximax approach, if they find oil after drilling for oil, they expect to generate around approximately $700,000 worth of net revenue. Okay, if they decide to drill and no oil is found, the question then arises: how much do they expect to? What will their revenue be? Net revenue be in that case? Okay. The next thing that we have to also ask ourselves is, what if we sold the land and oil was found? How much do we expect to gain? Okay, and in that case here, the total amount that they would expect to earn would be the sale price for that piece of land. Okay, and the same applies to a situation where they sold it and the buyers find no oil. this oil company would still have a net revenue of 90,000. Okay, so the only place where they would actually end up incurring a loss would be in a situation where they drilled for oil, and after drilling they realize that there's no oil in this tract of land, and in that case then the initial investment of 100,000 would be the net revenue. They would have lost 100,000. Okay, so with these options here, if we decide that we're going to use a max approach, we would look at the different values that we have here, okay, and ask ourselves, what's the maximum values amongst the different alternatives available to us, okay? And in this case here, if we look at the maximum value of revenue, you find it for the first state. If we decided that we're going to drill for oil, the maximum return would be 700,000. Okay. If we decided to sell the property, the tract of land, the maximum that they would receive would be $90,000. Okay. So the max approach is very simple in that it just looks at what's the best possible alternative. Let's choose that alternative as the one that we're going to assume is our most probable outcome. And let's use that and make a decision that we're going to drill for oil. Okay. So if you notice again, it's a very simple, basic way of trying to determine how exactly to make a decision. Okay. The second approach that the organization might have is what we call the pessimistic approach. Okay. And this is called pessimistic because we are just basically looking at it from the pessimistic side of what if what we expected to have occur doesn't actually occur. Okay. Can we minimize our losses? Okay, by looking at that approach that's going to maximize our revenues by pretty much looking at what's a maximum, what's a minimum amount for each row, for each alternative. And from those minimums, let's look at which one gives us the maximum return. Okay, so if we decide that we are going to drill for oil, we have two possible states. We're either going to find oil or not find oil. If we don't find oil, we make a loss of 100,000. Okay, that's our minimum. That's that first portion of, let me use my pen here. So looking at these two states here, for the Maximin approach, we first of all consider for that first alternative, which one gives us the lowest possible return. And once we've selected that, we compare it with the next minimum. And for the sale of the land, we have a return of 90,000 for each. So that becomes our comparative value. So now we'll be comparing 100,000 to 90,000. Or negative 100,000 versus 90,000, and basically the Maximin approach says compare those two values, and of those two minimums, which one is the higher value? That becomes the approach that we're going to go with. Okay, so in this case here, because it makes we have a higher value for selling the land conservatively, let's go ahead and sell the land rather than drilling for oil. Okay, so again, this approach is very basic. It's almost complete opposite of the first approach in that here we're using a more conservative, more pessimistic approach, while in the first approach, we are using what's called the optimistic approach, where we believe that the best outcome is the one that's going to actually occur. Okay. Now, obviously, in the real life of business, life is not that simple. We're just not going to take the best possible alternative. We have to factor in uncertainty. So these two approaches here do not factor in uncertainty. We're not using that 25% or the 75% criteria that we had here for the prior probabilities. So it makes sense for us to consider an approach that actually factors in the fact that, yes, there could be oil, but there's a probability associated with that availability of oil. Okay, so the maximum likelihood criteria takes us to another level, in that now we look at we look to see how can we incorporate your prior probability and come up with a value that's more in line with what we would expect to have given a situation of uncertainty. Okay, so how do we go about doing this? First, we look at what's the maximum values that we have for each and every state of nature that we have here. Okay, so if we look here, our maximum, we first start off by looking at what's the maximum probability. Okay, and the reason why we do that is that that's the probability, that's the state that we expect the most to happen, to occur. And so it makes sense for us to focus more on that. So in this case, we're told there's a 75% probability that the oil well or the drilling will result in no oil. Okay, so we decide that, okay, it's more likely that we're going to have no oil than it is likely that we're going to have oil. Okay, and if that's the case, then we now narrow our decision to just these two options to us. Okay, so now we forget about the possibility that there'll be oil and assume that, yes, our oil well might be dry. And if that's the case, the best option then would be what gives us the highest possible revenue. And in that case here, we go with the maximum of $90,000 if we decide to sell the property. Okay, so this approach adds more value in that now we are looking at that subjective probability and saying, you know what, chances are that we won't have oil, so let's go with that option that has the more higher probability of being the actual outcome. Okay, so this approach is good, but it still does not fully capture the different decision states that we can have in situations where we actually have prior probabilities. So the next approach, which is a Bayesian approach, a Bayesian decision rule, now factors in both prior probabilities, and rather than just focusing on the maximum approach, it also enables us to capture information associated with that lesser probability. Okay, so let me go back here and go into my Bayes. Okay, so the basic Bayesian decision rule basically says, let's consider both alternatives and go with make a decision based on the larger expected payoff that incorporates data on both prior probabilities in this case here. Okay, how do we go about doing that? A simple calculation associated with the probability multiplied by that outcome. Okay, so if I decide that we're going to drill and I want to figure out my expected payoff or expected outcome if we decide to drill, then we would multiply our prior probability by the anticipated revenue that we would get for that, and then add to that the second prior probability multiplied by its associated expected revenue. Okay, and with that, we come up with a new expected payoff, which is different from what we had in the previous example. Okay, and with that, now we end up with the drill option as being possibly our best option. Okay, our expected payoff is that at the end of it all, if we decide to drill using the Bayesian approach, we end up with an expected payoff of $100,000, which is higher than our option to sell, which would still be $90,000. Okay, so we do the exact same thing for the sell option, and that's how we come up with our $90,000. So in terms of what would be the best option, we would usually, from the examples I've given so far, the Bayesian approach is considered the better approach because it incorporates all the information available to you at the moment. Okay. Any questions up to this point? Because it gets slightly more complicated. But this should be pretty simple. It should be something you could do in Excel in a matter of minutes. So let's move on to, this is important. What are the different features? So the Bayesian decision rule accounts for all states of nature and the probabilities. It takes into consideration every piece of known information. So that's why we consider it the best possible approach. The other approach is just looked at what's the maximum, what's the best possible outcome, and let's use that and make a decision based off of that. Okay. There was something else that I wanted to mention here, which I might have forgotten. The criticisms. So the criticisms, when you look at the Bayesian decision rule, remember that these prior probabilities that we have here are subjective. It depends on the geologist, in this case, saying, I think there's a 25% chance that we'll get oil. Okay. So unless there's some information that can back that up, maybe from prior drillings, this is subjective, and it could lead to a situation where your decision making could be thrown completely off if that geologist didn't make the right decision. Okay. But it's a risk that you'd have to take because, again, we're operating in a situation of uncertainty and trying to come up with a solution, even though we know that our probabilities are subjective. Okay. So how do we go about doing this in a manner that most people who use decision analysis do? The decision tree is something that's used quite a lot, and chances are that you guys have seen this somewhere, used this in some other class. But let's review decision trees. So decision trees come in a format that usually is, if you are to draw a decision tree, I believe one of your homework assignments requires you to draw a decision tree. And so I'll just draw it. One thing to remember is that your decision trees will always be from the left-hand side of your screen to your right-hand side, okay? And your decisions are made in a certain given order, okay? You usually start a decision tree in a manner, let's actually go into a decision tree and I'll discuss that there. Delete this. And let's look at this. So if you look at a decision tree, you'll see a couple of shapes that accompany most decision trees. There'll be a square, there'll be a circle, there'll be a triangle. Each of those have a specific meaning, a specific purpose to them, okay? Now, let's start off with the square here. The square here represents a decision that whoever is making this decision has to make, okay? Now, that decision is subjective and usually depends on the, in this case here, it's a geologist who's going to make this decision. So this is a decision node, and the two options available to us here. You're either going to drill or you're going to sell, okay? If we decide to drill, now we go to our next level, and that's the event, okay? So an event node basically describes something that usually involves a probability, okay? The decision to either drill or sell doesn't really involve a probability. It's subjective to the person making this decision. But the event actually usually represents a decision that involves a probability because there are options available to you that you don't know the full outcome, and it's usually based off of that prior probability that you have, okay? So we have our event node here, which gives you the two options available to you if you decide to drill. You're either going to drill and find oil, or you're going to drill and end up with an oil well that has no oil, okay? And for a very basic example here, we have an outcome node here, which represents what's that final outcome of a situation where we decide to drill and find oil, we have our payoffs in over here. Okay, and this payoff here is calculated on the basis of those probabilities that we have here and those anticipated outcomes, revenue outcomes that we have. Okay. So if you go to the textbook at this point goes into a discussion of RSPE and how to use RSPE to calculate this. And as I said, I'm not interested in you using RSPE to calculate this. What I'm more interested in is, are you able to use a decision tree to calculate these given payoff figures that we have here? Okay. And the question that I have, that you would have is, okay, how do you go about figuring out that 700, the 100, the 90? And so let's go into a discussion of that. Okay. So let's look at the first branch that we have here, A, B, and the payoffs of 700. Okay. Now, the question that arises is, how do we determine what that payoff of 700 is going to be? If we go back to, we have this, yeah, what we have here. Okay. Basically, what we did is we've taken what we have on this table here and thrown it into our decision tree. Okay. So the first decision that we had to make was to whether to drill, which is what we have in our first row, or whether to sell. Okay. So we make that decision. We're going to, if you are to draw this in Excel, which chances are, you can either manually draw it and take a picture, or you can do something similar to this, where you decide you're going to either drill or you're going to sell. Okay. The decision to drill is accompanied by some probability. If we decide to drill and we find oil, there's a 25% probability associated with that, and there's a 0.75% probability that no oil will be found. Okay, those are second level decisions that are based on random factors that we really have no control over. Okay, and based on all of that, we can calculate our probabilities associated with every option that we have here. Now, the thing that I want you to get from this, apart from just drawing a tree diagram, is how do we use this to inform us on what to do? Okay, so RSPE has the ability, once you run RSPE, to determine, based off of whatever subjective probability that geologist has, to determine whether it makes sense for us to sell or to drill. Okay, and for you, the biggest challenge would be, how do we go about setting up this table here, where we make that decision to either sell or to drill? Okay, and for each option, if we decide to set a probability of, say, 15, if you set up your spreadsheet right, you should be able to determine what exactly that expected payoff would be with a given percentage of a given probability associated with whether we're going to get oil or not. And what I'm going to post, I have it's like a 10-minute video that I'm going to post to Blackboard after this, which discusses how to go about setting up this table here, such that you can make decisions on, based on a given probability, what options should we choose. Okay. I posted this spreadsheet to Blackboard, but it might not be as helpful if you don't have RSPE. So the next video that I'm going to post with the accompanying spreadsheet will be more beneficial, because I'm going to post formulas that'll pretty much have if statements And if statements just basically says if we decide to, for example, if we decide to drill, then, and so on and so forth. And then on the basis of that, your table here should be able to calculate what that expected payoff would be. Okay. Any questions on this before I continue? I'm still going to talk about this a bit more. And I'm in a hot room. All right, so I'll assume the silence means no questions. So when you talk of sensitivity analysis in situations where you only have the prior probability, you're basically asking yourself the question of what would be the effect of increasing your prior probability by a certain amount. So what would be the effect of, for example, changing the probability of getting oil from 25% to 30%? How does that impact our decision? Okay. And the only way you can get a solution to that is actually, the table does it well, but if you had to do this from scratch, you'd have to, every time you change that probability, you'd have to go and recalculate all the different figures in your calculation for the different payoffs that you have here, okay? Since you're a business student and somebody who might be using this in business, you don't continuously do that where you say, what if I think that the probability of getting oil is 50%, and then have to go back and calculate all the different payoffs. Okay, so this sensitivity table that RSPE runs here, and which I'm going to post to Blackboard, basically takes that out in that rather than having to rerun your decision tree each and every time, you're able to determine for every given change, how will that determine our decision, our ultimate decision to either drill or sell. Okay, so that's prior probabilities. Now, the one last aspect that I wanted to cover here is what about posterior probabilities? Okay, and when you talk about posterior probabilities, you're just basically saying, okay, we started off with a probability of 25% that we're going to get oil. But what if we could get new information that tells us differently, that advises us more in terms of what's the probability of us actually getting oil? Okay, and that's considered, it's called a prior probability, a posterior probability, where we get or acquire some new information and incorporate that new information into a decision-making process. Okay, so let's look at the same case and assume a situation where rather than rely on the geologist, they decide to acquire new information based off of seismic data from that specific area. Okay, and we're told here that that information can be acquired at a cost of $30,000. Okay, so that information expense of $30,000, that's an additional cost that when we're factoring in all the different aspects to this decision tree, we have to now factor in the fact that if we had to get new information, it's going to cost an additional $30,000. Will our anticipated outcome enable us to at least recoup that $30,000? Yes, no, okay. And so that enables us to start going to a discussion of posterior probabilities and how that then impacts our understanding of this uncertain availability of oil. Okay, so when we are dealing with posterior probabilities, use my pencil one more time, we end up having something that looks like this. Okay, and in this probability, which is an adjusted probability, is basically read as being the probability that a given outcome will occur, given that that specific state of nature that you're looking at is the true indicated one that you have. Okay, so say for example you decide to drill, okay, and your posterior information from the survey finds that there's a favorable seismic sounding, you have a high probability of finding oil. Okay, so that favorable seismic sounding can now be incorporated into your decision making. Okay, as a posterior probability. Okay, so how do we go about doing this? Let me go out of this. Clear. Okay, so for us to be able to calculate our posterior probabilities, we need to know what our prior probability was. Okay, so our prior probability for our first state was a situation where we're trying to find out the probability of actually getting oil. Okay, and our probability of getting oil was given to us initially as 25%. Okay, now posterior probability involves us incorporating that information plus any new information from that new survey and multiply that new information, and we come up with a new posterior probability of 0.15. Okay, so close this out and go back to my previous slide here. Okay, so the results of that survey that the company bought at a cost of 30,000 was that there's actually a favorable response in terms of the probability of us having oil. Okay, and that favorable outcome was given a 60% probability of 0.6. Okay, so with that new information and the prior information, we can come up with a new probability of what our actual probability associated with a given outcome is. Okay, now notice that we have a number of different potential outcomes given that new information available to us. We could have a situation where we end up finding oil and the survey reports told us that there would be oil, or was more positive towards us getting oil. Or we could end up with a situation where we drill for oil, find oil, but the reporter told us that there was no oil. Okay. The third probability we have here is the probability that we initially thought that the oil well would be dry, but the new information told us that there's a high probability that there would actually be oil. Okay, or the final probability that we could have here is that there would be that our prior probability was that there would be no oil, and the new report tells us the same thing, that there's a high probability that there'll be no oil. Okay, so all those end up giving us new probabilities here that we have to go back and incorporate into our decision tree. Okay, so we end up with a situation where we now have a decision tree that's slightly more staggered, and let me move this out of the way. We start off with what we knew initially. Okay, and we knew that we started off with a probability of potentially having oil at 25% probability of having oil, 75% probability of having no oil in the tract of land. And if we decide to go with what we have here, the next step in this decision tree would then be to incorporate whatever conditional probabilities that new survey finding got us. Okay, and that new survey enabled us to determine that yes, there's a much higher probability of having oil. Okay, and there's a 40% probability of not finding oil. Okay, according to the new information that's given. Okay, so with that information in mind, we now incorporate what we have for prior probability and this new information to come up with a new joint probability where we combine our prior probabilities and conditional probabilities. Okay, and on the basis of that information, the last step that actually gives us our true measure of posterior probability is for us to actually calculate a prior probability that's conditional on on what we have here, and let me go back out. Let me clear this drawings here. I think I skipped a step which I was supposed to. Okay. Yes, I did skip a step which we should have talked about. Okay. So once we've gotten those joint probabilities of the prior and the new information, we now want to find what's the probability of actually finding oil, okay? And we're going to use this information here where we look at two probabilities. What's the probability of one, finding oil? What's the probability of us initially thinking there was oil and then actually finding oil? And what's the probability of us finding out that there's no oil, but after getting new information, we actually find that that actually was not true, there was no oil, okay? So we incorporate this information into the calculation of posterior probability and come up with a number that we can now use, which is more informed than what we initially started off with. So we started off with a 0.25 as a probability of having oil. But now with this new information that we have, we can come up with a situation, we can come up with a more informed decision where we can say, yes, there's a 50% probability that if that new report tells us it's oil, there'll actually be oil. And there's also a 0.14% probability that we might find oil, given that our new report said that there might be no oil, okay? And so this is information that your new decision tree would incorporate to come up with a decision that's more informed, okay? So rather than just relying on our priors, this whole process asks us to figure out how do we incorporate information. And once we know this, we can go back and now calculate what are different alternative revenue outcomes on the basis of this. And the only difference that we now add is that if we decide to go with the new report, then we're going to have to add the cost associated with that report. I mean, subtract, not add, but we're going to have to subtract that 30,000 from whatever figure of revenue we have and come up with a new decision in terms of what's results in the highest possible revenue outcome. Okay. Questions? Any questions? Okay. All right. So for the sake of what I wanted to cover in chapter 9, I don't even take you this far, but it's worth considering that posterior probability is basically asks what's the value of new information? Should we commit to purchasing new information or acquiring new information? And if we do, is that cost going to be recouped if we decide to pursue the use of that new information? Okay. What I would require from you for the purpose of the homework assignment and also for the final exam actually ends right here with the expected payoff with perfect with the prior probabilities. So I don't expect you to do anything on posterior probabilities, but just to have an understanding of why would I need to discuss prior probabilities and posterior probabilities. What's the difference between those two? Okay. Questions on anything else? Let me see if I still have participants on. Prince?
Yeah, I'm here. No questions. I think I'll be able to figure this piece out. I think you said you're going to post.
Yes, I'm going to post a spreadsheet that doesn't include RSPE.
Okay, perfect.
But it includes how you go about actually doing those calculations in Excel with the type of formulas that you'd use. Okay, and I think that would be helpful for you even when you're doing your homework assignment.
Perfect.
Okay. All right, so I expect to, as I said, I'm going to review the grades for the first assignment and adjust any that had not yet been manually graded. And you should see that within the next 30 minutes or so.
Okay, perfect.
All right. All right. So I'll end. Yeah.
Just then, thank you for the session here. This was helpful. Do you think can I take the final at any time, or should I wait till I do the homework? Or
no, the final, because it's theory, you can do it even prior to doing the homework.
Okay.
If you can go through the theory of chapter 9, you should be okay with doing the finals. Okay.
Okay, cool.
Yeah. All right. All right then. So wait for the additional stuff I'm going to post to Blackboard, and you can use that for your homework assignment.
All right.
Okay. All right. You all have a good evening.
You too. Thank you. Appreciate it.
Okay. Thanks.